going to talk about linear quadratic systems. So when you studied in Algebra 1, you learned about linear systems where you had a linear equation and another linear equation, and you could have one solution, infinitely many solutions, or no solution. In this lesson, we're going to have one quadratic equation and one linear, and we can either have one solution, two solutions, or no solution. So if I were to graph my quadratic equation, so we'll have some kind of U shape, and then I graph my line, it could so happen that my line will just graze and touch at one exact point. That point of intersection would be one solution. If my linear equation comes and hits my quadratic equation, hits my parabola twice, that means I'm going to have two solutions. And if my line doesn't hit my parabola at all, I will have no solution. So I only have the option of one solution, two solution, or no solutions. So in order to do these, we are going to graph them and take a look at them and see how many solutions they have visually. So we'll grab our calculator. If you have something in there, take that out. So we have x squared and 2x. So if I graph those, I can visually see that I am crossing the same point here at 0, 0. And then also it looks like maybe 2, 1, 2, 3, 4. All right, I have 2 points of intersection, so this has 2 solutions. All right, let's take a look at the second one. We'll go in, change our equations out. So we have 3x squared, and we have 3x minus 2. Now, as you can see, these two do not cross at all, so this would have 0 solutions. All right, how many solutions could this system have? So depending on what this B is, we could have one solution, we could have two solutions, or we could have no solution. All right, so we're going to use something called Desmos. I've put these equations in already. All right, and I have added a little slider here. If we move the B, we can see as B changes, so that's the y-intercept of that equation. As the y-intercept changes, you can kind of see what happens to your graph here. So I can see that when B is negative 1, I could get that to stay on there. Negative 1, it looks like we are grazing right here at this one point, the point 1, 1. So to get one solution, my B value would have to be negative 1. So when B equals negative 1, there is one solution. All right, so let's go back. And so negative 1 gives me 1, which means I'm going to have more than one answer for the B as far as having two solutions. So as B gets larger than 1, I have two solutions. And so this is just going to keep going and going and going. And I'm going to have two solutions no matter what the B is, as long as it is larger than negative 1. So you actually have many, many solutions. So when B is greater than negative 1, there are two solutions. So that really only leaves one option for no solution. So if we get back down here to negative 1, when B is less than negative 1, our line and parabola are not going to cross. So when B is less than negative 1, there are no solutions. All right, so now that we've kind of talked about graphing and telling how many solutions there are, those points of intersection that you can visually see, Now we're going to solve by substitution. That just means that I'm going to solve for y in one of these equations, and then I'm going to plug that into the other equation for y and just substitute. That's why it's called solve by substitution. Well, I can see that this y is equal to this. That means that in the other equation, wherever I have a y, I can substitute all of this. So that gives me 2x minus, now because there's a minus here, I need parentheses when I'm inserting. So I have 3x squared plus 3x minus 5 equals, and then I have this 3 on the other side. Now it's just a matter of simplifying so that I can solve. So I am going to distribute the negative. That gives me negative 3x squared, negative 3x, and positive 5 equals 3. Now let's just combine like terms. So I have a negative 3x squared, 2x and negative 3x make negative x. And then I need to subtract 3 so that I can combine it with the 5 since they're on opposite sides. So that gives me plus 2 equals 0. Since I'm going to factor, I'm going to go ahead and divide all of these by negative 1 because I want my leading coefficient to be positive. So that gives me 3x squared plus x minus 2 equals 0. And then if I'm going to use my little tricks for factoring, I need a 1 in the front. So I'm going to take 3 times 2 and do my illegal move. X squared plus x minus 6 equals 0. And now I'm going to factor. I have a positive and a negative, x and x. And two numbers that multiply to make 6 that will subtract to make 1 are 2 and 3. And I need the middle to be positive, so 3 will be positive and 2 will be negative. Then I have to undo the illegal move. So that gives me x plus 1 and x minus 2/3. Now if I was just factoring, I would pull that 3 that's on the bottom there to the front. But since I'm solving, I really don't need to. So now I'm going to take both of those and set them equal to 0 and solve. So I have x equals negative 1 and x equals 2/3. So since I have two x values, I know I'm going to have 2 points of intersection. I have the x values, but I need the y values. So I'm going to take those x values and I'm going to either choose this top equation or this bottom equation. I'm going to plug in for x and solve for y. I'm going to use the top equation just because y is already solved for. So I have y equals, and then everywhere I have x, I'm going to replace it with negative 1. So I have 3 times negative 1 squared plus 3 times negative 1 minus 5, and that gives me a y value of negative 5. And then I'm going to do the same thing with the 2/3. 3 times 2/3 squared plus 3 times 2/3 minus 5. And that's going to give me a y value of negative 5/3. So my 2 points of intersection will be an x value of negative 1, which gave me a y value of negative 5, and an x value of 2/3, which gave me a y value of negative 5/3. And those would be my 2 points of intersection. Now, I could check those in my calculator, and I'm going to show you how to do that. So let's graph both of them. So I have 3x squared plus 3x minus 5. Now, the 2x minus y equals 3 is not solved for y, and if you want to graph something, you have to solve for y. So I solve for y. That gives me 2x minus 3. And then we're going to go and graph. All right, so I can see that I do have this point right here. Looks like they're crossing at negative 1, negative 5. All right, I have another point of intersection here, but I'm not quite sure. So I'm going to choose to plug in my own numbers in my calculator. All right, second window, make sure the independent is on ask. And then I'm going to go to my table, and I've already plugged these in, but I'm going to plug them in now. So negative 1, press enter. and I got 5 as an outcome. Now I want you to notice this. This is my y1 right here. All right? If I'm in my table and I arrow over, now I'm on my y2. Notice that I still get a y value of -5 when I plug in -1. Those should be the same exact number. All right, and then I'm going to plug in 2/3, so 2 divided by 3, which gives me -1.667, which is the -5/3. I'm going to arrow over, and I still get the same thing as a y value on the other. That means they share a point. All right, they share those 2 points. It's where they intersect. All right, so number 5, I see that y is equal to all of this. I'm going to take that and plug it into y here. So I have 2x minus, and then parentheses, plug in your 2x squared minus 6x minus 8 equals, and then you have that 16 on the other side. So now we're just going to simplify and solve, distribute that negative. So that gives me -2x squared plus 6x plus 8 equals 16. Combine like terms, so I have -2x squared. 2x and 6x make 8x. And then I'm going to subtract the 16 to move it on the other side with the 8. That gives me -8 equals 0. Now I do notice that all of these will divide by 2, and I'm going to divide by -2 because I want my leading coefficient to be positive. So divide everything by -2. So I have x squared minus 4x plus 4 equals 0. And then I'm going to factor 2 minus signs with my x's. And what multiplies to make 4 that will add to make 4 is 2 and 2. Now I have the same exact factors, so there's no need for me to set both of them equal to 0. So I set the x minus 2 equal to 0. I am only going to have one point of intersection because I only have one x value. And then the y value of that point, I'm just going to come up and plug into this top equation. You could do the bottom, but I'm doing the top. So I have y equals 2 times, and then I'm replacing x with 2 squared minus 6 times, replace x with 2, minus 8. That's going to give you a y value of -12. So when I have an x value of 2, I get a y value of -12, and that is the only point of intersection between those two equations. All right, so on number 6, again, I see that I have y equal to all this. I'm going to replace this y with all of that. Now I'm going to kill 2 birds with 1 stone here, and I already know I have to distribute this negative. So as I write down this in place of y, I'm going to go ahead and change the signs. So that makes this a positive 3x squared, a negative x, a -4, and then we have equal to 2. Combine your like terms. So we have 3x squared, 4x minus 1x is 3x. And then I'm going to go ahead and subtract this 2 to move to the other side, which gives me -6 equals 0. I notice that all of them divide by 3. So we'll divide by 3. That gives me x squared plus x minus 2 equals 0. And then I'm going to factor. I have a positive and a negative. And what multiplies to make 2 that will subtract to make 1 is 2 and 1. And I need the middle to be a positive 1. So 2 will be positive, 1 will be negative. And then I'm going to set those equal to 0. So I get an x value of -2 and an x value of 1, which means we're going to have 2 points of intersection. Now I'm going to plug those in. Y equals -3 times -2 squared plus -2 plus 4. That's going to give me a y value of -10. Then I'll do the same thing and plug in 1. So -3 times 1 squared plus 1 plus 4. That gives me a y value of 2. So my points would be an x value of -2 gave me a -10 y value. And an x value of 1 gave me a y value of 2. And those are my 2 points of intersection. All right, number 7. I'm going to take the y up here and plug it in for y down here. Now, since this y does not have anything in front of it where I would have to distribute it, I really don't need parentheses. So I have 3x squared plus 7x minus 10, and then minus 19x equals 22. Combine like terms, so I have 3x squared, 7x, and negative 19 make negative 12x. And then I need to subtract that 22 so I can combine it with the negative 10 on the other side to make negative 32, and that's equal to 0. All right, these don't all divide by a number, and what you will find when you try to do the illegal movement factor is this one is not factorable. So in order to solve, you have to either complete the square or use the quadratic formula. I'm going to use the quadratic formula. So A is 3, B is negative 12, and C is negative 32. So we have x equals negative b, but b is already negative, so this is 12, plus or minus the square root of negative 12 squared minus 4 times a is 3 times c is negative 32 all over 2 times 3. Now, I already know that this is not going to come out to be an integer, so and also not a pretty number at all. So we're going to just plug this all in at the same time. Now we have two answers here. All right, one involves the plus sign and one involves the minus sign. So we're going to go to our calculator, and we are going to just plug all of this in. So I'm going to get myself a fraction, and I'm going to say 12 plus the square root of negative 12 squared minus 4 times 3 times negative 32 all over 2 times 3. Press enter, and we're going to round 2 decimal places, so the nearest hundredth, that would be 5.83. All right, so that'll be my first answer. And then I need to do the minus, so I'm going to go up and press enter and select that. And the reason I'm doing that is so that I don't have to type this whole thing out again. I can just come over and change that to a minus instead of a plus. So our other x value is negative 1.83. So we have 5.83 and negative 1.83, and then we're going to plug those in. So y equals 3 times 5.83 squared plus 7 times 5.83 minus 10. That gives me a y value of 132.76. I'm going to do the same thing with negative 1.83. So 3 times negative 1.83 squared plus 7 times negative 1.83 minus 10. That gives me a y value of negative 12.76. So my 2 points of intersection will be an x value of 5.83, which gives me a y value of 132.76. And then the other would be an x value of negative 1.83, and a y value of negative 12.76. So those are my 2 points of intersection. So if you cannot factor, then you can use the quadratic formula. All right, Andrew kicks a ball up a hill for his dog Leica to chase. The hill is modeled by a line through the origin, and the path of the ball is modeled by the quadratic function that is shown. How far does the ball travel horizontally, and how far must Leica run up the hill to catch it? All right, well, I already know that the horizontal distance is represented by the variable x. I can see that on my graph, okay? The path of the ball is what the quadratic equation is. I'm looking for where it lands, okay? So that point right there on the hill. All right. Now, obviously, if this is an accurate picture, I can tell that it's something that's above 10. All right, but this is how I'm going to figure that out. I want to solve for x, which means if this is the y, I can plug it in for this equation for the y, which is what I'm going to do. So I have 0.5x is equal to negative 0.5x squared plus 6x. So I'm going to get everything on one side. I'm going to subtract this 0.5x. All right, you have a calculator, but if you think of this in terms of money, if you had $6 and you took away 50 cents, you would now have $5.50 equals 0. Now I only have two terms here. I could do the quadratic formula if I wanted to plug 0 in for c, but these do have a common factor, so I'm going to factor out the common factor of negative 0.5x. So negative 0.5x squared divided by negative 0.5x is x, and 5.5x divided by negative 0.5x is negative 11 equals 0. And then I have my two factors. I'm going to set them both equal to 0. All right, and then we're going to solve. So I divide by negative 0.5. So x is equal to 0. I add 11. So x is equal to 11. So obviously, it's going to cross that line that we have showing up here 2 times. All right, one of those times is here. The other time is up here. Well, when the ball has not been kicked yet, we have traveled horizontally 0 feet, and then it crosses again at 11. So that makes sense. So this is 11 feet. So from here all the way to here is 11 feet. All right, the other question is asking how far Lake had to run up the hill. Well, that would be this section. Well, that is like a diagonal of a right triangle. If I want to figure that out, I first have to know how far it is from bottom to top. That would be your y value. So I have my x. To get the y, I'm just going to plug into the equation. You can choose either one. So 0.5 times, plug in 11, and that's going to give you 5.5. So I know it's 5.5 feet up vertically on this hill. And then I just have to use the Pythagorean theorem to figure out that hypotenuse. I want to solve for the hypotenuse. So c, the hypotenuse, is equal to the square root of one of the legs squared plus the other leg squared. And if I plug that in, that's going to give me 12.3 feet. So Leica has to run 12.3 feet up the hill. And keep in mind that if you got something 11 or smaller, that can't be because the hypotenuse is always the longest side, so it would have had to be bigger than 11. So that's one way to kind of gauge if you're on the right track. All right, revenue for the high school band concert is given by the function y equals negative 30x squared plus 250x, where x is the ticket price in dollars. The cost of the concert is given by the function y equals 490 minus 30x. At what ticket price will the band make enough revenue to cover their costs? So we need to know what the ticket price is going to be when these are equal. All right? So I can take this and plug it in for this y right here. So I have 490 minus 30x equals negative 30x squared plus 250x. I'm going to get everything on the same side, and I kind of want my x squared to be positive, so I'm going to add the 30x squared. I'm also going to subtract this 250 so that I can put it with the negative 30. That would give me negative 280x. And then you have that 490, and that's equal to 0. And all of these will divide by 10. So if you can reduce these, you should definitely do that. Just makes it easier on yourself. So we have 3x squared minus 28x plus 49 equals 0. Now this is another one that is not going to factor, so we will do the quadratic formula. A is 3, B is negative 28, and C is 49. So x is equal to negative b, but b is already negative, so 28 plus or minus the square root of negative 28 squared minus 4 times 3 times 49 all over 2 times 3. Now, We're going to do this just like we did number 7. You're going to plug in the positive version and the negative version, and you are going to get outcomes of 2.33 and 7. Now remember, this is a cost. At what ticket price will the band make enough to cover the revenue? That's going to be between $2.33 and $7. So make sure that you refer to that as money, and you would round to decimal places because when we talk about dollars and change, it does have 2 decimal places.